Hello students, let us learn about how to get a single sideband suppressed carrier wave. Let us learn it from the spectrum point of view. Consider any signal, any random signal whose maximum frequency is B hertz. Any random signal, right? So since signal is a random signal, we say that maximum frequency is B hertz, so that we can draw only the spectrum of the signal. So suppose this is the spectrum of the signal. This is message signal. We can draw a spectrum like this. So maximum frequency is B hertz. Suppose if we take this in terms of hertz, okay, this is minus B. This is your signal M of the spectrum of the signal M of t, which is called as M of F. Right? Now, once you multiply the signal with the cos omega ct, and we can see that once M of t is multiplied by cos omega ct, if you want to get the spectrum of that, that is Fourier transform of that, we can use shifting property. Using shifting property, we can get the spectrum of a double sideband suppressed carrier wave as, which you can see here, with the frequency omega c. So I will write the frequency in terms of fc here and minus fc here. So what happened? The entire spectrum will be shifted to plus fc and minus fc. You know that. So M of t multiplied by cos of omega ct. So if you see this in the frequency domain, suppose the Fourier transform pair of this is M of f. The Fourier transform will be M of f plus fc plus M of f minus fc. This is what you get. So if you plot this M of f plus fc, M of f minus fc. So then this will be carrier, this will be carrier frequency. So carrier frequency doesn't exist, but it will have a upper side band. It will have upper side band and the lower side band. It will have a upper side band and the lower side band. This is the upper side band. Don't forget this, right? And this is going to be the lower side band. This is going to be the lower side band. This is your upper side band. One is your lower side band. Okay? This is your upper side band. This is your lower side band. So this is total is 2B, right? This is B. This is B. So total is 2B, and this is FC plus B. This is your FC minus B. So total bandwidth will be 2B. So bandwidth is going to be the 2B only. But this is double sideband suppressed carrier wave. Right? Now how do we remove this? How do you remove one of the sideband? Right? So to remove one of the sideband, the best way is to use a band pass filter, right? So now see here, I will take the same signal here. So suppose if I want to remove, right, this is going to be the F, remove upper side band or keep only lower side band. So I will use a band pass filter, okay, whose frequency width will be only this, okay. I will use a band pass filter whose frequency width will be only this, right? So see, this is your band pass filter. This is your band pass filter. This is once again, I will write filter as H of F. And this filter is the band pass filter with the cutoff frequency FC minus B to FC. See what happens when you pass this through a filter of transfer function H of F. That means it is multiplying by, it is just multiplication. In frequency domain, it is just multiplication. So when you multiply this signal and this signal, so what you will get? What you will get when you multiply these two signals? Filtering means you are multiplying in the frequency domain. So that means when you multiply these two, what you will get? So you will get only this part, right? Only this part. So what you will get is something like this. Right? You will get only this. And you will get only this. This is what you get. This is lower side band. Upper side band will be removed because this is 0, right? This is 0, right? This is 0. So, and this multiplied by 0 is 0. So what you get is this. This is your lower side band. Upper side band will be removed. Upper side band will be removed. We can see here, this is the upper side band. So USB is removed. This is simple filtering technique to remove the one of the side bands, right? See what are you doing? You are multiplying this, okay? You are multiplying this, your double sideband suppressed carrier signal with this. This is the transfer function of a band pass filter, okay? And its cutoff frequencies are FC minus B to FC, only this one from here to here. So what it will do, it will pass only this frequency. It won't pass any other frequency. So what is going to be available is this only lower sideband part, which is from FC minus B to FC, right? So this is what required. Suppose if you want to, only upper sideband, you change this. You change the band pass filter to FC plus B. So you will get the upper sideband. Hope all of you understood this. This is called simple filtering method of removing the one of the sideband. Hope all of you understood this.